This video will demonstrate how the inSure monitoring device provides operators with the lift data during an overpressure event in real time using the inSure app or connected to their DCS system. By measuring lift of the valve disc off the valve nozzle, the device provides percent open details. The user can not only track relief events, but can also calculate a more accurate discharge volume. We will be using a standard Ferris 2600 series relief valve with a wireless heart-enabled inSure monitor installed and connected to the inSure app. We will then export the data and use it to show details of the relief event. This valve is set to relieve at 108 psig air pressure, and our test stand will be used to simulate a fully open cycle as well as a partially open cycle. We will start by demonstrating a valve in the fully open state. While connected to the app, we will see live data output from the app, as well as the vessel pressure as we ramp up the set pressure and then to full open. With the vessel pressure at 60 psig, we will ramp up the pressure until we begin to see lift. We are nearing the set point, and you will begin to see the valve simmer, and then you will hear the valve pop. Note the monitor output immediately detects the valve opening and provides a percent open reading. We will continue to increase the accumulation pressure until the valve is fully open as shown by the monitor output. Now that we have reached the fully open state, we will hold it here for about 15 seconds and start decreasing the pressure to show blowdown performance. As you can see, the output shows the valve status is closed and percent open to be 0. Here is the output data file showing valve position every second through the cycle. We will now take the same valve set to 108 psig and simulate a partially open cycle. Starting at 100 psi, we will slowly ramp up the pressure until we begin to see lift. You see the monitor is reading 0, meaning the valve is closed. When we get near the set point, once again the valve will simmer and pop, resulting in the app showing the valve open. Now that the valve has popped near the set point, we will maintain or slightly lower the pressure to keep the output reading around 65% to 75% open. By limiting the inlet pressure, we will simulate a partially open valve. We will keep it here for about 20 seconds and then decrease the pressure until the valve has fully closed, showing blowdown performance. As you can see, the output results on the app provide real-time critical data. Here we have exported the data from the app to an Excel file and plotted so you can see the results showing valve position every second through the cycle. Now this data can be used to calculate the release volume of the event much more accurately than assuming the valve is fully open and at full relief pressure throughout the cycle. In this case, using nitrogen at ambient temperature, the calculated product loss is about 28% less than assuming the valve is fully open.